All right, so hello everybody. Today we are going to solve some questions from the ASMO test. So let's start from year 5 and 6. First of all, as you can see in this food chain below, what would probably happen if this duck or population R were to disappear? All right, so a food chain is when energy is transferred from one source of one animal or plant to another. And the energy goes in the arrow shown. So what this means is that, for example, the snail will receive the energy, not that the plant eats the snail, but the energy is transferred. So knowing that, if the duck were to disappear, the animal here, aka animal S or the fox, will not have anything to eat, right? Foxes can't eat snails unless there is an arrow pointing to the fox over here. In this case, there isn't an arrow. There's only the fox and the duck, meaning that if animal R were to disappear, then population X will go to another area to find food because there isn't any food. So either that or population S might die out because there isn't enough energy. Now, now rainbow or the effects of a rainbow is basically a multicolored arc resulting from many spectrums of lights. It is very beautiful, some might say, and is seen via water droplets with being shined from behind by the sun. Now, reflection and refraction helps this formation of this rainbow. So, can anybody tell me why what wait, oh yeah. What is this phenomenon that leads to a rainbow? What causes the rainbow in the first place? Is it reflection? Is it dispersion? Is it polarization? Or is it diffraction? I'll give you some time to think about it. All right. So it is not A because reflection is when light bounces off a surface. Now, now polarization is something you will learn in the future. And also diffraction. But in simple terms of polarization, it's kind of like blocking a range of light so that you could only get one type of wavelength. So yeah, and diffraction is also something that should be kept for another time. So it's the dispersion. Dispersion is when something separates into lights of different wavelengths, which is in this case different colors. So now, so now I will give you a hint. So you know the rainbow colors, red, orange, and we know the rainbow colors, right? Yeah, we should know the rainbow colors. Now, one thing about the rainbow colors is that it goes from a low wavelength to high wavelength. Now, low wavelength starts at red. Red has the lowest wavelength of all, and violet has the strongest wavelength of all. So, as slowly as we shift the hue into the additive direction. So if we turn from red to orange, then our wavelength will increase. So based off that, and we use a color wheel or something like that, how would they be arranged? Okay, this question is kind of like a trick question over here because there is no purple in a situation like this. Purple is not a thing. Instead, we consider this color as indigo. Indigo is a replacement of purple. But other than that, most of the other things are correct. With violet being the highest wave, having the highest. Wait, sorry. I didn't. I said some wrong things. I meant that low wavelength is for fast things like this, like violet, while the higher wavelengths is for red, colors like red. I meant it the other way around. So wavelength is basically the distance between one high and one low. And to have a higher wavelength, you must have a higher frequency. A shorter frequency beats a shorter wavelength. Yeah, so I apologize for that. But in the but from highest to lowest wavelength, B will always be true. Just remember, purple is not in a rainbow, and purple is not in a rainbow, and yeah. Now, an incident ray is projected to a less dense medium. What could be observed if the light enters the denser medium? What do we think? All right. So, all right. So, in a lesser dense medium, you will not expect for the light to reflect at a greater angle as it used to. It will not retract as well. This is not what happens. In a light that goes into a less dense medium, you will see the light to refract at a smaller angle. And as you slowly go into lower mediums, it will become a circle type shape, but not really a circle. So yeah. Now, each category of food provides different nutritional value. Which following of food would be the best source of energy? Alright, so let's break this down. Tomatoes and watermelons are vegetables. They are not sources of energy. They will not give you energy, and they are there for the nutritional value, basically health, vitamins, etc. While boiled milk does sound like a good thing because milk is filling and does give you energy, but that falls under the dairy category. It will usually not give you a lot of energy compared to something like a sweet potato. Wait, sorry. Compared to something like a sweet potato. A sweet potato is not a potato, unlike what people think about. But both of them are very starchy vegetables. They have a lot of starch into them. Therefore, it makes you very full and gives you a lot of energy. This is why usually you would probably be eating them and you would be full easier than other vegetables. But just remember, sweet potatoes are not vegetables. They're carbohydrates. And similarly, they are not potatoes. They're its own kind. They just have the same name because they look like potatoes, and they're not grown like potatoes. They're grown in a different way, but they're named sweet potatoes for some reason. Now, Xingming, I believe, took 4 slices of bread and placed them under the following conditions. So, after a week, she saw that some of the bread has mold. Now, which of the bread has mold? Is the question here. Alright, to break this down simply, mold likes moist things. Toasted things do not have enough water for mold to grow. So, if we base it on that, we could assume that both conditions A and B will create mold. Toasted bread is dehydrated hot bread, or just dehydrated bread. There's a reason why it's not soft. The water makes it a bit softer than usual. Having no water makes it really hard to us and also the mold. So under conditions A and B, the bread is moist, so it will lead to mold. Now, in definition of physics, force is an energy, power, or strength which is able to change the movement, direction, or physical appearance of an object. There are many types of forces, for example, tension, friction, air resistance, gravitational, and magnetic. So, based on this, what would be the most important forces for a plane to take off? Now, we can easily eliminate option A over here because option A is tension and magnetic force. Yes, it is correct that planes do use magnets. However, they are not essential for the plane to take off and are more used for navigation. Friction is also not useful for us over here because friction slows things down. That's for landing, not takeoff. So obviously, this would be wrong. Now, now both of the answers look right, right? I mean, they're basically the same thing. They're basically resistance, force, and irresistance. However, however, it is actually it is actually B that's right over here. Because resistant force is not a thing. Resistant force is something that's made up. The only thing that we know is air resistance. Air resistance exists. Resistant force is not a thing. So air resistance and gravitational force is the answer. All right. Thank you.